Hello, welcome to another session of the Houdini Training. My name is Gianvito Serra, and this is one of the many sessions that we're going to be doing for learning VETs and VOPs inside of Houdini. Because VETs and VOPs is such a great feature inside of Houdini, I figured I will have a series, just dedicated to showing you few examples of how you can actually use VETs and VOPs to actually do certain operation types. Okay? So this particular time, we're going to be looking into how to make changes to lower LODs apply back to higher LODs on the fly. Okay? So for that, we're going to start with a geometry node. And then I'm going to start with one of our test geometries. So just repeat that. Let me go ahead and actually do that a little bit slower. I press tab, and I'm going to type geometry. Double click to go inside, and then I'm going to press tab again, and I'm going to look for a test geometry. So if we go to the test geometry section, you will notice that we have several test geometries that we can use for different operations. For this, I'm actually going to use the pig head, which is simply a head that looks like a pig. Okay, I'm going to hide the grid so we can see a little better. One of the advantages of the pig head is that test geometry is that it actually comes in different levels of detail. So for example, we can switch this difficulty parameter to easy, and we get a lower res version of it. Okay. So what I want to do is to actually have a high res version. I'm going to delete this file operator, which we don't need, and I'm going to Control C and Control V this head and then have a low res version. Okay. So we have a low res pig head and a high res pig head. It's very typical in productions that you may have a less detailed model version of a high detailed model version, which you use maybe as a stand-in, maybe as a lower LOD. For different reasons, you may actually have a low res model. Okay. Another typical situation that happens in productions is that somebody may come after you're done, texturing this and surfacing this and making this all beautiful. Somebody may come along and say, well, you know what? I want to grab this model and I want to go ahead and change it. I want to make it a little bit heavier. Okay, so we're going to grab, for this particular thing, I'm going to do that again. I'm going to drop an edit operator. Okay, the edit just allows me to do edits on this model. And I'm going to make sure that my little icon handle here is on, so that I can just go and do live edits on this model. Okay. So what I'm going to do is I'm just going to do a few edits on this. Okay, and I'm going to go ahead and actually see the effect of this. So let's go ahead and actually pick a point here and then maybe pull it. I'm going to go ahead and give it a little bit of soft radius. Maybe not that much, it's a little too much. You can probably turn on mirroring too to see a little bit of that effect over there. Actually, I think if I turn on mirror at the very beginning of my operation, then this actually will behave probably a little better. There we go. Yeah, there we go. But again, like I said, not that much. It's probably like about here. We'll pick here. We'll also go a little bit heavier here. Let me increase my little radius here a little bit more. Basically what I'm doing is just, imagine that at one point somebody comes over and say, hey, you know what? We need to make our pig a little bit heavier, for this particular shot that we're doing, or this particular game character that we're doing. Okay, a little bit more forehead here, and the art director comes, you know what, I want the ears to be a little bit higher, and then we go and make the ears a little bit higher. Well, that's great, but I already modeled my higher LOD and it looks this way. Now it's supposed to actually look this way. Okay, just for fun, I'm going to actually make the cheeks just a little bit bigger. There we go. So this is a very typical situation in productions when late changes come in based on direction, and we need to figure out a way to cope with this. Okay, so this is where I think certain operations inside of VOPs can really come handy inside of VETs. That's what we're going to show here. Very well. So the first thing we want to do is that we want to be able to actually see the difference in between this guy and this guy. Okay, so we want to try to understand how this actual model changed before it so we can apply those changes to this particular asset. Okay, way how we do that is by simply doing and we're going to actually do this with an actual attribute, an actual point VOP. Okay. So in the point VOP, you'll notice that we have multiple inputs that we can use. We have, input 1, input 2, input 3, and input 4. Okay. If you remember from the last lesson, the point VOP is an operator which allows us to operate on points. All right. So what we're going to do in here is that we're going to dive inside, and if you remember from the last lesson, there is all these different parameters that we have as inputs and all these different parameters that we have as default outputs. Okay. And in here, you will notice that we have operator input 1, operator input 2, operator input 3, and operator input 4. So we have 4 operator inputs here. If we go back up, you will notice that we also have 4 little plugs here. That's because, for every single input that we have here, we can bring the actual operator that is from the outside through any of these little plugs right here. Okay, this is just a means for us to say that we want to reference the first input or the second input of a particular operator. Most operations in Vex allow you to actually bring any object from any part of a network. You can just do any kind of operator path and pass it as a string. But for these purposes, we'll be able to use these plugs here. Okay. So first thing we want to know is to know the difference in between this guy who is going on the input 1 and this guy which is going on the input 2. To do that, we simply use a subtract node. Subtract. Okay. The subtract operator simply takes one input, like in this case is the position in this case, and then it takes another input and it just subtracts them together. Okay. But in this case, though, we need to do is subtract the second position. Okay, we need to subtract this position from this position to get a difference. Okay, the difference of change, if you will. So first thing that we need to do is that from input 2, we need to figure out the actual position. Okay, to get any attribute from any of the inputs here, we can use a get attribute operator. So there is get attribute. We can fit the second input into the actual file. Okay, the reason why it's called file here, by the way, is because this particular operator has the ability to even use a geo file or a BGO file or an OBJ file that is in disk. But when you actually wire a input into the file operator, it ignores the actual external file and it just uses whatever is being fed into the plugs of a network. So in this case, it's just going to take whatever is coming from this wire, which in this case is the heavier guy, and using it here. Okay, so it's taking the heavier guy and applying it here. And then another thing that we wants to know is what is the attribute that we're trying to bring in. Okay, so in this case, we want to bring in the point attribute, which is the position attribute, which is P. And if we middle mouse on any of these nodes, we can see that we have a point attribute called P, which is the position coming in from really any operator. Has always a position attribute. See that? And that just stores the position of a point. Okay. Next thing to remember here is that these two meshes have the exact same topology. Okay, for this particular example, the geometries didn't change. They just were displaced together, so they had the same point count, right? So what we want to do is to get the position for each point at a particular point. Okay. The way how we can do that is to simply feed the point number that is being currently processed into the first input of that, which is the actual pointer primitive input. Okay. All that is doing is saying, okay, go to the second input. Okay, look for the point that matches the currently point being processed and get its position. Okay, so I have now the position for every point that I'm processing here. So this operator is processing every single point, is looking for the equivalent point on this input to figure out, okay, what the actual position at this place is. Okay, So now that we have the two positions, we have this is the position, the original position, this is the change position. We can subtract from the new position the original position, okay? And that gives us the actual difference of the in-between from this guy to this guy, okay? And what I want to do is, I can, for example, output it as a color so we can see. If we look at this here, you will notice that I have a color map representing like the difference in between both of the actual, between this guy and this guy, okay? What's even more interesting is that if I add this position, if I add this difference to the position, we go add, and we add it to this position, and we feed it to the position, we get the exact same modified version of a mesh. That's because we're basically calculating the difference in between the two and then adding the difference to the original position, okay? It's very cool. But in a particular case, I don't want to add them together, okay? I don't need to pass this wire either. And I also don't need to actually display it as colors, okay? So I'm going to disconnect this. Although it really doesn't make a difference, a lot of times I leave this connected anyway, just so that I can visualize my data very easily as it is actually changing, okay? One thing that is neat is that I can still go back to this edit operator, and as I do edits to this particular asset, you will notice that my colors immediately change to reflect those changes that I'm doing, which is really, really amazing. I mean, one of the beautiful things again about Houdini is that everything that you do is completely live at all times, okay? This is equivalent of in any other program to be writing a C++ operator that cooks this stuff on real time, okay? Very cool. So now that we have the difference, what I want to do is, instead of putting in the color, I want to actually stuff it into an attribute, okay? So if you middle mouse, here, you will notice that I have only two attributes, which is the color that we see here and the positions of a point. Well, I want to create a new attribute called the difference to store this actual change, okay? So the way how we do that is that we use a bind export operator, okay? And the bind export is just a means for me to get any variable out of this exported into an attribute, okay? So I am going to make this attribute a vector attribute, okay? And I'm gonna call it def for difference, okay? I'm gonna pass the difference variable into this. And if we go back out and we middle mouse here, you will notice that now we have a new attribute called difference, okay? And if we right click and look at the spreadsheet, you will notice that now we have a difference attribute right here for every point, okay? Which incidentally matches the color because we're actually just displaying it as a color, okay? Very cool. So now the next step is how to apply the difference to the actual high-res model so that the high-res model takes up the changes from the low-res model, okay? And we're gonna do that with another point VOP because this is a VOP exercise, okay? So for this particular case, what we want to do actually, and let me delete this, is that we want the point VOP to be on this guy, okay, because we want the point VOP to modify the high-res model, and we want the low-res model as being the second input of this particular operator, okay? Let me reorganize my notes a little bit so we can see a little bit better. And I'm gonna name this so that it's a little bit more clear of what's going on here. So this is the pig head lower, and then this is going to be the pig head lower modified, okay? And this is gonna be the pig head higher, okay? Okay. So now we have in the second input this geometry which has a difference attribute which calculates the difference of all my points. And the first input we have the high-res model, okay? So the cool thing is that if you look at this, this model and this model actually look very, very close together. Okay, this model and this model do not. Okay, because obviously this model has changed quite a bit. But because these two models are very close together, it's very easy for us to actually trace from this high-res model to this low-res geometry and figure out what our change needs to be. Okay. So the way how we do that, if we go inside of this point VOP, is that we want to first figure out a way from this model to get that difference attribute that we created on the low-res model. Okay, there are several ways that we can go about doing that. For this example, we're going to use an HYC distance VOP. Okay, what the HYC distance VOP does is that it looks at one model, in this case this model, and another model, like this model, and just finds the closest intersection point for every point of the first model into the second model. Okay, so let's do that. So I'm going to go ahead and actually go and say that for my HYC distance, I want to look into the second input, okay, which is my lower res mesh, and I'm going to use my position as the actual query point. Okay, so this is going to give me output the distance that it takes for each point to actually find a particular hit, the primitive that it hit, and the actual UV position where it actually hit. What's really nice about this is that we can actually pick up not just the position at each point, but we can, for example, pick up the blended color in between points. Like, for example, a point may find a closest point around this surface or around this surface. It won't try to pick up this point's difference. It will pick up the difference at this location, giving us a much, much higher level of precision than if we were sampling points. Okay, very cool. So now, once we actually have the HYC distance, okay, this already gives us the actual values. Okay, we need a way to actually pick up that difference attribute. Okay, in order to do so, we can use what is called a primitive attribute VOP. Okay, then remember the name of it is primitive, as in primitives, and attribute, as in attributes. Okay. But what the primitive attributes allows us to do is that given an input, okay, and given a UV location and a primitive number, we can actually pick up any attribute we want at any point in the surface. Okay. Well, this is great because we have all that information that it needs. Okay. So we need to figure out what input we're using. So we're going to feed the second input into the file. And the attribute that we're looking for is the difference attribute, which we call diff. Okay, so that's great. We already have two of the things that we need. Okay, the HYC distance, when an actual point finds the closest surface point, it will return the primitive number. Okay, so we can actually feed a primitive number back into the primitive number here. In addition, it will also return the UV location where it hits. So basically, if you look at a primitive, it will give you like the interpolated location and where it hits, and we feed that into the UV location. Okay, so that now gives us, if we actually feed this to the color, the very same difference attribute which we saw on the low res model, but applied in the high res model. So that's great. Now that we have that, as you saw before, all that we have to do is to simply grab the position and put an add VOP, take the output of the prim UV and feed it to the second input of the add VOP, and simply feed that to the position. And there we go. Now we had a version of a pig which matches closely to the version of a pig that has been modified. Look at that. So if we actually put, for example, a switch node to see, you will see that we indeed are able to pick up the art director changes right into our pig. Not just that, we can simply go back to the actual modifier node, okay, and we can go ahead and keep modeling on it if we want to. So say for example, pick this point, and then put, and actually go to this guy, and go ahead and edit this guy. Let me see. And say for example, move the ears, and both changes will update on the high res and the low res model. Okay, so we can simply keep modeling on the low res model and see our changes on the fly on the high res model. And as you can see, these changes are pretty much in real time. It's very responsive because again, we're working in VOPs or VETs. It's very fast. I mean, as an operation, it runs on SIMD architecture, which makes it really fast. One thing that is fun is that even the small little mistakes that we had from the low res to the high res get transferred over, so that everything is kept as it was. You know, so every little change that we did to the high res from the low res is maintained, so that we don't ever have to reapply those changes anymore. Okay. So we can make the nose a little bit bigger here if we want, and all sorts of changes that we may want to do to actually make this model whatever we want to. But the beautiful thing is that we have to do them once. The art director can do whatever they want, and we get the final model updated. Oh, I don't think I want that edit there. There we go. Very cool. So that concludes this exercise. Thank you for watching. My name is Gianvito Serra, and we'll be continuing to do some more of these little VETs tutorials. Thank you very much.